Next up, we have oral presentation 34, iFORWARD-Grantsburg, Wisconsin Mission 12 Flight Experiment.
First of all, I wanted to thank all of you for staying for the last presentation, so yes.
Grain size and distribution analysis of gallium and microgravity. iFORWARD is an online public school, and our students are dispersed across the state of Wisconsin. Our co-principal investigators are Grace Mulliken, Anita Finch, Dominic Parker, and Andrew Nichols.
Our teacher facilitators are Mr. Ron Cerveny, Mrs. Constance Quaddy, and Mrs. Jenna Winder. We are partnered with Carthage College and the University of Wisconsin-Eau Claire. So gallium, well, why did we choose it? In the past, I've watched videos on YouTube about gallium. Gallium has always amazed me how a substance that claims to be a solid turns into a liquid by just the heat of a hand. I've watched videos of people just melting gallium in their hands, to gallium fidget spinners, and even gallium slime. We've also had to discuss, how can gallium help us in the future? Well, if humans were to ever live on Mars, gallium could help build and repair things. Gallium could also help us here on Earth, with car and even computer parts.
So gallium, what is it? It is a metallic substance with the property of being able to melt in the palm of your hand. So gallium's atomic number is 31, its melting point is 85.58 degrees in Fahrenheit and 29.76 in Celsius. Gallium is a lot like mercury in some ways, but it is not poisonous. It can stain. I found that out the hard way while experimenting. The symbol for gallium is Ga and is in group 13 on the periodic table. Gallium can alloy. What does alloy mean? It means two pure elements mixing together to make one strong metal. So you're probably wondering what semiconductors, transistors, and light-emitting diodes are. First things first, what is a semiconductor? A semiconductor is a solid substance that is used to connect circuits. A transistor is a semiconductor device that has three connections and is used for amplification and rectification. Light-emitting diodes are also known as LEDs. LEDs are used for Christmas and decoration lights, computer parts, LED light bulbs, etc.
Gallium is a very special metal, and it does very strange things under certain circumstances. And microgravity is something that does stuff to it. When exposed to microgravity, the grain size and structure will be changed, and so will the melting process. As you can see in the first picture, there are three different examples of what can happen to steel when it is treated differently. We are referencing steel to show how different metals react to heat. Different metals have different grain structures that are built up in unique ways. The metals and their structures are classified into 5 different groups, as you can see in the second picture, and it just happens to be that gallium is put in the other category. As you already know, gallium is a soft metal that melts or freezes easily, so easily in fact that you can do it in your hand. If it melts well enough in space, it can actually be used in space. So if it does good in space, it could be beneficial.
Experiment setup. Our experiment is done in a fluid mixing enclosure, or FME, which SSEP requires. The FME is a silicone tube that we put gallium in with end clamps to keep it from leaking. In the FME, we take 10 grams of gallium molded by a straw into a rod, and the reason that it is a rod is because everybody's hand temperature is different. With the gallium being so small, it will hopefully take less time to melt, and then we clamp it into place like in the picture below.
We are working with Dr. Douglas J. Dunham at the University of Wisconsin-Eau Claire. The university has world-class equipment and experts. The university has developed a way to polish the gallium for the preparation of the experiment. We have polished the gallium by using a water-cooled grinding and polishing process to avoid the metal melting in the process of flight.
Testing process. By using a combination of optical and electron microscopes, comparisons of grain size and distribution can be made between the ISS sample and the ground truth sample. The Reference for the chart comparison method is shown in figure 1.3 below.
Thank you to Grantsburg School District, Carthage College, the University of Wisconsin-Eau Claire, Dr. Kevin Crosby, and Dr. Doug Dunham. Thank you so much for your time and staying here for the last presentation. Is there any questions?
Hi, my name is Griff, and I'm from Stamford, Connecticut. So you mentioned in your presentation that in like Mars, if we like settle, we could use gallium to like repair buildings and stuff like that. Has this idea already been done on Earth, or is it just like an idea that you guys thought of that could be used in the future?
It actually was all us. It has not been done yet. We're hoping that it freezes well enough in microgravity so we can use it in Mars and on Earth.
Okay, thank you.
Hi, I'm Ian from Burleson, Texas, and I was asking why use gallium when you could use a much more stable element like copper?
Because gallium has not been used for many things. It's only been used for like replacement for mercury in thermometers, and we honestly think it should be given a more stable chance in microgravity and space, so that if we need other metals to be used for building and car parts, then we could rely on gallium.
Thank you.
I have two. Oh, Gabriel from Burleson. I have two quick questions on this. On continuation of his, you said that it might be used in car parts and stuff like that. That stuff tends to get pretty hot and can get over 100 degrees. Well, over 100 degrees, over that 85 degrees, and it can melt. But so why would you use that if it could maybe get over that temperature?
So actually the university is thinking of a way to keep it as like colder so it's more stable to be used in car parts, and we're hoping that it is more of a solid than a liquid. It is going to be tested for that, and hopefully we find a way so it can be used here on Earth.
And my other question on that was, gallium, when you actually, I've noticed this because I've used it before, when it actually turns into a solid, it's fairly brittle. So how would that work also?
Well, there are things, alloys. So it could also, we could mix it with other metals to make it not as brittle. It can also be more stable when it is mixed together. Like I said, it's used for semiconductor. It's used for a lot of computer parts and replacements for thermometers. So, yeah, that's a good question.
Okay, thank you, ma'am.
Thank you.